Hello everyone, in this video, I will show you how to create sodium chloride crystals, commonly known as table salt crystals. We will explore the step-by-step process, understand the science behind crystallization, and discuss the fascinating structure of these crystals. Let's begin! The materials we need are simple and easy to find. First, we use table salt, which is sodium chloride, glass mug, hot water, tablespoon, and petri dish. First, prepare all the materials that we need. After heating about 100 ml of tap water until it's warm, but not boiling, pour the hot water into a glass. Then, slowly add table salt to the water and stir continuously until the salt is fully dissolved. Keep adding salt until no more dissolve, which it will create a saturated solution. Once the solution is saturated, let it cool to room temperature. Then, pour the solution into a clean petri dish and leave it behind any undissolved salt. To prevent dust from contaminating the solution, cover the petri dish loosely. Place the dish in a warm, undisturbed location where it won't be accidentally moved. Over the next few days, water will evaporate and salt crystals will begin to form. To increase the chances of getting well-formed crystals, prepare multiple samples. This way, even if one sample has imperfections of gets contaminated, you will still have other samples to observe. Check the petri dish daily and observe the growth of the crystals. You will notice cubic shapes starting to appear. These are the characteristic structures of sodium chloride. Here are the short physics fundamental explanation of solid state theory. The structure of sodium chloride. Sodium chloride crystal is made up of sodium ions, that is cation, and chloride ions, that is anions. Sodium chloride crystal is a face-centered, cubic close-packed structure. The chloride ions, being comparatively larger in size, occupy the corner and face-centered positions. The sodium ions, being smaller in size, goes to fill up the voids. Thus, sodium ions occupy the octahedral voids in cubic closed structure. On extending the structure, we will see that each chloride ion is surrounded by 6 sodium ions, while each sodium ion is surrounded by 6 chloride ions. So, the coordination number is 6. Now, let us calculate the total number of ions per unit cell. Total number of chloride ions per unit cell is equal to sum of chloride ions at the corners and at face centers. The total number of chloride ions is equal to 8 corners multiplied with 1/8 per corner plus 6 faces multiplied with half per face, which equal to 4. Then, the total number of sodium ions per unit cell is equal to sum of sodium ions at the 12 edges and 1 at center of cube. So the total number of sodium ions is equal to 12 edges multiplied with 1/4 per edge plus 1 ion in the center, which equal to 4. Thus, the unit cell of sodium chloride which is NaCl, contains 4 chloride ions and 4 sodium ions.